So what if you're dealing with the case that the standard deviation of population is not given to us? What should we do then? So if your sigma is not given, instead of finding z, we're going to find t. So let me erase these. Okay, and for the margin of error, we have a different formula. And for calculator also, we use a different formula. So what if standard deviation of population is not given to us? It means that we do not have this ZC. It means that we cannot use this formula. What should we do then? If sigma is not given, if sigma or population standard deviation is not given, then you follow step one. Step one, what is the sample mean? You need to find your sample mean, definitely. Then find the confidence level. Step two, stay the same. C or confidence level. In step three, the critical value follows T distribution. So step three, there is no ZC. We find critical value T sub C. And in step four, the margin of error E is equal to T sub C times S, which is your sample standard deviation, divided by square root of N. S is your sample standard deviation and N is sample size. And finally, go to the last step, step 5, find your confidence interval, which is X bar minus E, X bar plus E. So confidence interval, X bar minus E and X bar plus E. These are the steps that we have to take. Let us take a look at one example. In this example, you randomly select 16 coffee shops and you start measuring the temperature of coffee sold at each of those coffee shops. So what is this 16? When you encounter each number, you have to stop and think about what is that number. Very good. So what else is given to us? It says, hey, the sample mean. Hey, I have a keyword. Sample mean temperature is 162 degrees Fahrenheit. What is this sample mean? Is it X bar or is it mu? Which case is this? So sample mean is 162 degrees and the sample standard deviation is 10 degrees. Sigma is not given to us, so it is just the sample standard deviation, which is S. Question says, well, construct a 95% confidence interval for the population mean temperature of coffee sold. We don't have all of those coffee shops. We took a random sample. We calculated the temperature, average temperature of those sample. And then we know that the standard deviation of the sample is 10. Question says, construct 95% confidence interval. So let us go to the board and construct that. Very good. So based on the information that is given to me, what do I have? The sample mean is 162 degrees. confidence level, it says, hey, 95%. These are given in the question to me. We find the critical value, TC. Guys, note that the population standard deviation is not given. What is given? The sample standard deviation is given, which is 10. We need to find the critical value, TC, and go to E, which is equal to TC times S divided by square root of N. Note that N is the sample size is 16 coffee shops, and S is sample standard deviation, which is 10. So let us find T sub C, the critical value. Very good. So we are building the T distribution for this sample that we have, and the information that are given to us is the level of confidence, which we know that is 95%. What we need to find is the degrees of freedom. The degrees of freedom is n minus 1. So to identify TC using T-table or the website, we need to find the degrees of freedom, which is sample size minus 1. Sample size is 16. So 16 minus 1 gives us 15. The degrees of freedom, 16 minus 1, or 15. So let's take a look at our table. By looking at our table, we can find 15, which is the degrees of freedom, and 95%. The intersection between these two gives us the number 2.131. 2.131. Okay, you can use your website as well to calculate the TC, but this is the easiest way to use your calculator. 95% confidence level, and the degrees of freedom is 15. The intersection is 2.131. 2.131. T sub C, 2.131. Another piece of information that we found. Now let us find the margin of error. Margin of error is saying that, hey, you have TC. I have my TC, 2.131 times S. S is 10 divided by square root of 10, square root of 16. So what is my E approximately? So 5.33 or 5.3. We found everything we need. So confidence interval, which gives us the interval, the range of numbers, the temperature of coffees in the population. We don't know how many coffee shops are there. We have no idea. We took a sample and then we found the average temperature, and we are constructing a confidence interval. So it is x1, which is 162 degrees minus 5.3 degrees, and 162 plus 5.3 degrees. So let's do the calculation. Here we get 7.6156, and then here we have 167.3. So we say that, hey, we are 95% confident that the average temperature of coffees is in between 156.7 degrees and 167.3 degrees. This is our observation. Very good. So now let us take a look at our calculator, but note that this is the case that we do not have any Z. We have to switch to T. So turn on your calculator to find confidence interval, go to stat, Go to tests. Now you need to find not the Z interval, but the T interval. So go to T interval. Very good. We went to the T interval. Are we using the original data? No, we don't have the original data. We have information about the original data. So we go to stat. What is X bar? So we'll go to stat. X bar, the average temperature is 162 degrees. 162 degrees. What is S? Sample standard deviation. You know that is given to us as 10 degrees. So 10, and then M, the sample size, is equal to 16. And then, okay, I forgot to change it. And the confidence level, C level, is 95% or 0.95. 0.95. Calculate for me. It says, hey, the confidence interval is approximately 156.67 and 167.33 degrees. So it means that the average temperature of the population or coffee in the population is between 156.67 degrees to 167.33 degrees. And we are 95% confident about that. 95% confident that the population temperature falls within these two numbers.